Okay. Okay. I think it's on now. Alright, let's start. Hello everyone. Thank you for joining this coffee break with Eddyfi. So today's topic is going to be handling dual array probes with GEKKO. So I've got a camera on the block here, you can see here. I've got a dual linear array, I've got a dual matrix array, I've got the GEKKO here. So for those of you who are not familiar with dual arrays, so basically here is one, the dual linear array. That's one phase array transmits and sends the sound into the material, and the other one picks it up, picks the echoes up. So here I've got a dual 64 element linear array. So one 64 element probe transmitting and one 64 element probe receiving. So that's a regular G3 casing with a wedge designed by my esteemed colleague Fred Revadi. Basically, who's been simulating that to optimize both the range of action of the probe, but also the size of the wedge, so that's minimal. And here I've got another example. That's the a dual matrix array. So this one is 2 times 28 elements. Each probe here is a matrix of 4 by 7. So I'm going to start with the dual linear array. So here I've got the GEKKO driving this probe, and this one is 2 times 64. So the architecture of the GEKKO is 64-128. And you should see the capture interface, which is basically a screen capture of the GEKKO, so you can see clearly what's going on. All right, so let me swap here. So that's the probe here, maybe a better view. So I've got only a stainless steel block with a couple of sideway holes. We're going to see how we image that in a minute. So now, why dual probes? So let me swap screen here. There we go. So dual probes, or TRL probes, transmit, receive longitudinal, are a well-known technique by the NDT phased array trade to deal with difficult materials that are heterogeneous, anisotropic and attenuative. So anyone dealing with CRA, so that stands for corrosion-resistant alloys, or crack-cladded welds, casted austenitic stainless steels, or just stainless steel parts, knows the inspection challenges. So we can't use shear waves as they are not traveling easily in these materials, and pulse echo methods are producing too much noise. So the industry has been using TRL probes for a while now, and when we use such probes, we reduce the noise, the dead zone, and we can also reduce the size of the wedge. So to know all about it, I encourage you to surf the Eddyfi website and search for crack, CAS, and dual probes keywords. You will find the application notes that I'm browsing in front of you now. So basically here, that's the application note about the dissimilar metal weld inspection. So you can find all the information, the challenges, a brief overview of the software and solutions we see fit for this. We've got also a large library of coffee breaks, webinars, videos that you can replay at any time with the Eddyfi On Demand website. Here another app notes here on the catalog for the application notes with phased array. You got that for all the techniques dealt with by Eddyfi Technologies. Yeah, you can download, simply click, browse, and download. So here, that's another application for dissimilar material welding testing with the beam simulation and the kind of imaging we can achieve with GEKKO. And of course, you've got the web page of capture. I'm going to spend a bit of time with the capture interface here, but you can go directly on the Eddyfi web page and browse through the main features for easy access. All right, so let's get real. I'm going to show you this guy now, the capture interface and the block with the my setup right here. So again, so I've got the probe here, so the dual linear array right here. I've got a splitter that is 2 times 64 that's hooked up on the GEKKO, and these probes are hooked up on the splitter, so everything is hooked up. And what you see here is live, so let me grab this window right here. So here I'm on the probe setup of the capture interface. You have many tools to configure very easily your dual array. So in the first tab that says configuration, you can set the frequency. On the dicing tab, you have access to the numbering and still the WYSIWYG, the what you see is what you get parameters right here. So on the numbering, we've developed an interface that is very easy to follow. Basically, you can choose the numbering of your channels depending on your probe wiring. So we've been confronted to many probe manufacturers. Everybody's got a way to wire it. For dual linear array, that's not too difficult. You can swap increasing order or decreasing order. For a matrix array can be trickier, but we've got the same tool right here. So if I click on the numbering, you've got all the two matrix transmitting and receiving, and you can flip vertically, flip horizontally, mirror, transpose the wiring, so you can match any probe manufacturer wiring here. So once you're happy with your setup, usually you follow the spec sheet of the probe manufacturer and match it with the capture interface. Now you can work on the wedge. So the wedge here, the same. We got a WYSIWYG editor. So here the roof angle between the two probe, the transmit and the receive probe. Here I've got 3.8 degrees. If I enter different values, say 20, you can see immediately what's going on the screen. So you've got an angle that is much greater now. And if I had this much of an angle, I would have a very limited range of action. But that's part of the wedge design. So, and we can do the same with the gap. So here I've got a 13mm value. Of course, you can work in inches, but being natively fluent in millimeters, I stick to it. So if you put 5 here, you can see the two probes are getting closer to each other. Let's put the correct value right here. And you can put a squid angle as well. So you can really design your probe in a very easy way. Alright, and that's not the end of it for the dual probes. Now we got also the wedge calibration. You're very familiar, people who use capture are very familiar with the GEKKO wedge calibration tool, and we've got exactly the same here for the dual arrays. So basically you enter put a bit of gain. Let me clean that. Grab a bit of a tissue here to clean the wedge. And now I've got a much better echo, and I simply click measure, and that's it. I've got the wedge angle and the wedge height automatically updated. Right here. So you can save this probe into your library, including the transducer and the wedge, and you can save it with the date. Basically, that accounts for manufacturer specifications, but also wear and tear. So you calibrate it, you're 100% sure that you got your wedge design right. And every parameters are here summarized here on this window, and you can also customize the picture. Nothing new here, but I'm going to show exactly this. So the wedge calibration, it's done. Now let's go to settings and play with the focusing. So let me browse through here and go in the edit panel of the TFM settings. So let me find, alright, a bit of coupling, always. Alright. we go. So now you should see. So you've got the block and the echoes of the side wheel holes. Here I'm doing basically TFM plane wave imaging setup. You can see here there is the grid verification, which is the amplitude fidelity. So this setup I have got here with L-wave at 3 MHz is a setup that is code compliant. So make sure, so if you want to see all the details of this, of the way to do it, again, go on the Capture web page, you'll see the webinars, you'll see the how-to notes explaining this very in details. So I'm going to skip through this step here. Right, so that's basically this zone is almost 2-inch wide by 3-inch thick, and let's check the speed we can achieve with that. So yeah, the max scan speed with 1 millimeter step, so it's 120 millimeter a second, so basically 5 inches a second, with a dual array that is 2 times 64 element, code compliant, imaging like a 6 square inches zone that goes 5 inches a second. So that's quite fast. So let's, but that's not the end of the setup. We've got also to do TCG. Now we are code compliant. So if you are going to do weld inspection, you want to make sure you've got a TCG. It's a nice tool to use in the field. So right here, so press OK and go on the TCG. Again, I'm not gonna I'm going to show you briefly the interface. You press play, you scan. You've got this in videos on our website many times. So I'm not going to go through that. I saved it for you, so I'm going to load it. There we go. Oh, this guy. There we go. So now you can see that it corrects the amplitude for each line of the zone, each column of the zone. So I'm code compliant. I've got a TCG. I've got also an encoder with me. You can see it here. I think that's the wire encoder here. You can see it on the camera. Yep. I'm checking at the same time with the YouTube live setup. All right. And so this is just a simple wire encoder. So apologize for the block, the side wheel hole, side wheel holes block, and the string encoder. That's all I could grab from the lab before we were confined. So I'm gonna show that to you nonetheless. All right, I go to inspection. I'm ready to go now. All right. So I'm gonna basically here what I'm gonna do. I'm gonna fake a lateral movement, just pulling the wire encoder. So I just press play and pull this. All right. And then I'm gonna show you the analysis of this very difficult inspection of side wheel holes. Scan is done. Alright, so I've got like a scan, T scan here. I've got A, B, C, D scan. So if I browse my cursor, you can clearly see all the holes. And I'm not going to go through all the analysis tools that we've developed on this version of Capture. Fred already did his last coffee break on the analysis tools, and there is also a webinar on it coming with more details. Plenty of references on these features recently released. I just can't resist to show you the 3D view here. All right. Put a bit of gain right here. It's recomputing the image. There we go. So I can remove the T-scan and show the 3D view. my probe and the side holes over this block. And everything is on board the unit. You can see pretty image, so basically you can do the full analysis with all the ABCD scan tools, the measurement tools, the indication tables tools, the auto sizing features, and you can use the 3D rendering for easy reporting. Yeah, if you missed the previous analysis, a coffee break, you can replay it. You just have to subscribe on the YouTube channel from Eddyfi. Alright, how am I doing about time? Oh, I went quicker than expected. I'm going to conclude this, and I'll see if there are any questions, and maybe I'll show the dual matrix array, and I'll check out the questions to see if I should steer the end of it towards a particular direction. So basically, to conclude on this feature, the dual array probes on the GEKKO, so you can handle large channel count dual phased array probes. You've got all the tools to onboard the unit to set up, calibrate, encode, and analyze your data. You can ensure your setup is code compliant. You can apply TCG to your weld inspection configuration, and you can use whichever technique you see fit to your inspection. So it could be a phased array UT beamforming, it could be TFM FMC, or it could be TFM plane wave imaging. Each technique has got pros and cons, but it's always a plus when you have the full toolbox with you in the ditch without having to go back to a computer or to change unit because you don't have any enough channels on the unit and you need more. So with GEKKO and Capture, you have everything handy, and I hope I've shown today how easy it is to use a dual array. If you have any questions for later, there is the support m2m@eddyfi.com. You should see it on the screen. And let me check. So I'm gonna go on the YouTube live right here. To see if there are any questions. So YouTube. Oh yeah, let me check. So I'm gonna go. So without the sound, yeah, it's got a bit of a delay. Can you show phased array UT data with a dual matrix? All right. So let me go back to the cam here, GEKKO cam. So basically, I'm gonna swap this with. So what was that? Dual matrix. All right. So I'm gonna swap probe. I'm gonna use this one here. Yeah, smaller aperture, smaller unit, smaller probe. Let me unplug and replug the other one. I gotta find the plug. All right. All right, and then let me reload this guy. So I'm leaving this guy and I'm gonna reload. I prepped it for you. So phased array with a dual matrix. So the dual matrix is right here, and right, that's my 4x7 matrix, transmitting and receiving. And okay, so here it's already computed, so I'm just going to show you like the phased array settings. All right, with a bit of coupling always. Here we go. So here I'm a bit generous with the gain. Let's decrease this. Here, 3D rendering scene, phased array, no problem at all either, so you can really pick your technique. So you can do sectorial scan and choose your type of focusing as well, of course. Alright, let me check another question. How easy, quick question, how easy is it to achieve amplitude fidelity with a dual phased array? Well, it's really the same as with a regular probe, with a pulse echo probe. Actually, let me, amplitude fidelity is for TFM, so let me load, since I'm not with a dual matrix, I'm gonna load it with FMC. There we go. So here you can see that I've got the TFM setting, the FMC setting with the same probe. It's always interesting to see that no matter the technique, and you can see the physics, ultrasound still travel. But yeah, going back to the grid verification, you click right here, you enter a menu, you select the echoes you want to do the amplitude fidelity on. You put a box right here. Maybe here I've got too much gain. There we go, you put threshold and you click compute. So you let it work for a while. What it does, it's also recalled in the webinar on the release of 3.1. It does many TFM images while moving the grid, so to make sure that we don't change the amplitude while we're moving the grid by a tiny portion of a wavelength. And that's how it's defined in the ISO standard and the ASME standard. And right here you can see I've got a half a dB, and the standards say I can go up to 2 dB variations. So I click OK, I've got a green light. I can see my amplitude table right here. I can copy and paste it into the report, and now you know that you are code compliant. If I click OK right here, now I've got a green check on my grid verification, my amplitude fidelity. Alright, what else? Dual matrix done, amplitude fidelity done. Dual array probes should be part of any basic kit for inspector doing PAUT. Well, fortunately, you don't need dual probes for every inspection, but for all difficult material where you need to, where you were using the dual probes before, whether it was a conventional or phased array, now you can also do it with TFM and pen wave imaging. And if you've got dual probes, bring them on with the GEKKO. That's you've seen. I hope I've shown you how easy it is to use with the interface. So yeah, it's part you can handle like challenging material with this. All right. How am I doing time-wise? It's 24 minutes. All right. Let's see if there are any more questions. Did I miss some? No. Yeah, so, well, if that's the end of it, I might just stop here. I'm gonna wait 1 more minute. Maybe I'll show here on the probe numbering, just to recap a bit of everything. Adjust the parameters of your dicing, calibrate your wedge, specify your wedge, calibrate it, compute your delays, Make sure you've got amplitude fidelity if you're in TFM, FMC or TFM plane wave imaging. Make sure you got a TCG for welds, always advisable. TFM is just another technique of phased array, so you need to do TCG on your welds, and that's it. Let me check here. All right, well, all right, I think I'm going to stop here. So Tony, I think you can stop it. Thank you, Veronique and Tony, for making this happen. And next week, I think we've got one to show you the Mighty Panther with Laurent Lebert presenting you next week. It's going to be announced shortly. So stay tuned and see you next time. Thanks. Bye bye.